solving exponential equations. We'll throw an algebra 2 twist to this. There's a video online for an algebra 1 version of this. We go a little deeper on this one, okay? So here's what we have so far. So we have 3 to the x, so this is a little review of algebra 1. 3 to the x plus 1 equals 3 to the 5th. All right, so notice both the variables, or the variables is in the exponent. If the variable is in the exponent, we want to get that variable out of the exponent, okay? If they have the same base, which these two do, right? 3 is my base here. If they have the same base, then you could do a nice easy technique here. You could just drop the base for both of these, and you have x plus 1 equals 5. That's only when you have the same base. And you solve. And you get x is equal to 4. Pretty easy. Okay? So assuming both these exponential equations or exponential expressions have the same base, 3 to the x plus 1, the other one's 3 to the 5th, you could drop the 3 from both of them and just set the exponents equal to each other. All right, so that's ideally what we want. For this section, we will be able to manipulate this. We'll either have the same base or get them to be the same base. For the next section, we will not have the same base, and I'll show you one of two ways to solve those. Okay. So here's another one coming at you. 6 equals 6 to 2x minus 3. My base is 6. What's the exponent of the number on the left? 6 to the first. Okay, so we have 1 equals 2x minus 3, and we solve this. All right, so the bases go. See you later. Add 3 to both sides. 4 equals 2x. Divide both sides by 2. X equals 2. Okay, I'm not really worried about that part for you guys. I know you guys got that. The part that you guys need to know is you have to have the same base here. Once the bases are the same, just set the exponents equal to each other. Questions so far? All right, next one. Again, same base. Take a second, see if you've solved that one. All right, so I'm hitting 3 across the board. Again, I'm just going to drop my 10s here. So 3x equals 2x plus 3. Bring over the 2x, subtract 2x from both sides. X equals 3, and you're done. All right, let's ramp these up a little bit. Now let's use some rules of exponents that you've learned this year and in Algebra 1. All right, and this is more of an Algebra 2 look, okay? So if you have x to the 3rd times x to the 7th, what's my answer? X to what? X to the 3rd times x to the 7th is x to the 10, right? Just add your exponents, right? Rules of multiplication. Same thing here. My base is 6 for all of these, so I'm going to keep my base. So the left side, all I'm going to do is take this exponent, negative 3r plus 3, and I'm going to add it to this exponent, which is 3r plus 2. Equals, and then you have that negative 2r here. The rest is just solving a multi-step equation. Negative 3r and positive 3r simplify out. 3 plus 2 is 5, so you get 5 is equal to negative 2r. Divide both sides by negative 2. See you later. R is equal to negative 5 over 2, and you're done. Same thing, rules of division. So if you have x to the 6th divided by x to the 3rd, again, you're dividing here. What do you do with your exponents? This becomes 6 minus 3, and you subtract these, okay? Same thing here. So my bases are all the same, so I'm going to take this negative n minus, I'm going to take this n, and it equals 3n plus 1. And then just put them all together. Negative 1n is negative 2n equals 3n plus 1. Bring over the negative 3. Negative 5n equals 1. Divide by negative 5. And then n is equal to negative 1/5. Okay? Your base is all the same, so this time I'm going to take negative 2a plus, okay, because I'm multiplying, multiply your exponents, equals 4. All right, so I added these two exponents, that equal to the 4th. Negative 2a plus 2a is 0. 0 equals 4. That is no solution. They both have the same base of 7 here, but this one has the 5th root and the x. How do I rewrite this? Think about your last quiz.
7 to the 1/5.
Okay, so this is 7 to the 1/5. So this is 7, and it'll be x over, just joking, 7 x over 5, right? The 1/5, but you have your exponent here, and then the root is on your denominator. So equals 7 to 2x plus 3. So I'm just going to rewrite that first and then do this, okay? And now I'm just at, okay, they both have the same base. Let me set these equal to each other, and you're good to go here. For this one, I don't care what technique you use here to solve this, but if you want to, you could clear your fraction, multiply everything by 5, and you get x equals 10x plus 15. You just clear your fraction multiply all three terms by 5. You don't have to. Okay, you could subtract 2x from both sides and get a fraction there, same thing. All right, and then subtract 10x from both sides. You get negative 9x equals 15. Divide both sides by negative 9, and x is equal to negative 5 over 3. My first one is no big deal. 12 to the 2x minus 1 equals, and I'm going to rewrite this 12 to the x over 4th power. So you got 2x minus 1 equals x over 4. Again, however you want to approach this, I'm going to clear my fraction, multiply everything by 4, make this a little nicer. So you got 8x minus 4 equals x. Bring the 8 over, you get negative 4 equals negative 7x, and then divide both sides by negative 7, and you get x equals 4/7. First one, 6 to the 2x over 3 power equals 6 to the x plus 6 over 2. Good. So you have 2x over 3 equals x plus 6 over 2. I don't know what you did at this point, but you could have easily done this. Cross multiply. 3 times x plus 6 equals 2 times 2x, 4x, 3x plus 18 equals 4x. Subtract 3x from both sides, and you get x is equal to 18. You have 625, 125, and 25 as your basis, so they're not the same. Okay. For this particular quiz, you can convert these to have the same base. So how can you write all three of these, 625, 125, and 25 with the same base? Well, they all have a base of 5. So 5 to the first is just 5. 5 squared is 25. So I could rewrite that as 5 squared. 5 cubed is 125. So I could rewrite this one as 5 cubed. And then 5 to the 4th is 625. I could rewrite this one as 5 to the 4th. All right, so I need to make sure they all have the same base. So my first one, 625, I'm going to write as 5 to the 4th, and that's to the 2b power. Times, my next one is 125 is 5 cubed, but I don't want that fraction there, so I'm going to do 5 to the negative 3rd power. And that's all raised to the 2b plus 3b plus 3. And then lastly, 25 is just 5 squared. So now I have a common base of 5 through all. Right? So 625 became 5 to the 4th. 1 over 125 became 5 to the negative 3rd. And 25 became 5 squared. Now that I have a common base between all of these, I'm going to take one more step here. You might skip the step over next couple problems. But I'm just going to rewrite this a little cleaner. So I'm going to multiply these two. So I have 5 to the 8b times this. I'm going to multiply these two. So this is 5 to the negative 6b minus 9. And it equals 5 squared. And then lastly, I'm going to go back and do exactly what I did. I'm going to take now all my bases can drop. So I have 8b plus negative 6b minus 9 equals 2. Well, I could just do, so this becomes 8b minus 6b minus 9 equals 2. Combine like terms, 2b. Bring over the negative 9 to that side as a positive 9. 2b equals 11. Divide both sides by 2. And b equals 11 over 2. Common base here is going to be 4. 4 to the first is 4. 4 squared is 16. And 4 to the third is 64. So I can rewrite these all at base 4. So continuing, I'm going to do this as 4. This 4 to the 64th power is 4 cubed to the negative v power times 16 is 4 squared to the negative 2v power, and this one's fine as it is, 2v power. So I'm going to multiply these two. So I get 4 to the negative 3v times 4 to the negative 4v equals 4 to the 2v power. All right, then drop all these. See you later. And you got negative 3v plus negative 4v equals 2v. Negative 7v equals 2v. Bring all your v's to one side, so I'll bring these all over. So I'm going to add 7v's to both sides. Add 7v to both sides, you get 0 on the left. There's nothing on the left. Equals 9v, divided by 9, divided by 9. V is equal to 0. Next one. So this v, so I got 27, 1/3, and 9. 3 is your common base here. Okay, so 3 to the first is 3. 3 squared is 9, and obviously you don't have to write all this stuff down, and then that's the 27, okay? So 27 here I'm going to write as 3 cubed to the negative n minus 2 power over, I don't want a fraction here, so I'm going to write 1/3 as 3 to the negative first power raised to the 3n minus 3 power, and then equals 3 squared. And clean these up a little bit. I'm going to combine this part here. So that's 3 to the negative 3n minus 6 over 3 to the negative 3n plus 3. And all I'm doing is just multiplying those equals 3 squared. I have division here, so I'm going to take this quantity here, negative 3n minus 6, minus, and I'm going to take the second quantity here, which is negative 3n plus 3, and equal this to 2. The biggest mistake I'm going to anticipate here is you guys not distributing your negative here. So negative 3n minus 6 plus 3n, and then minus 3 equals 2. Combine like terms, negative 3n and positive 3n. See you later. So now all your terms with variables are gone, so therefore it's either infinite solutions or no solutions. The left side, negative 6 and negative 3 is negative 9, and negative 9 does not equal 2, so therefore no solution again. Common base here is 6, so I'm going to rewrite 36 as 6 squared, and raise that to 3r plus 2 power, times, 1/6 I want to write as 6 to the negative first power, raise that to the r minus 2 power, and then 1/6 again, I'm going to do 6 to the negative first power. All right, so now everything's at base 6, and then I'm going to combine. I got 2 times the quantity of 3r plus 2, which is just 6r plus 4, plus I'm going to add this quantity here, which is going to be negative r plus 2 when I distribute that negative. You can write these all out. You can do it right there. It's up to you. And then equals negative 1. Combine like terms. 6r minus r is 5r. Positive 4 and positive 2 is positive 6 equals negative 1. I'm going to subtract 6 from both sides. You get 5r equals negative 7. Divide by 5. Divide by 5. r equals negative 7/5. All right, 1/4 can be written as 4 to the negative first power raised to the 1 minus a. Okay. 16 is just 4 squared raised to the 3a plus 3. And again, I need a common base of 4. 1 is 4 to the 0 power.
Wait. Because I canceled out.
And now all my bases are 4, and now I can work and just solve all my equations. So the first one is, my first exponent is negative 1 times that, which is negative 1 plus a. Plus, the second quantity here is going to be, when I distribute the 2, it's going to be 6a plus 6. And all that is equal to 0. And then we're going to combine some like terms, move some things around. So I got a and 6a is 7a. Negative 1 and 6 is positive 5 equals 0. 7a equals negative 5. A equals negative 5/7. Common base here, what do we use, 5 or 25?
25.
How many people use 5? All right, I'm going to use 5, most majority rules. All right, so 1 over 625. 5 to the 4th is 625. So I'm going to write this as 5 to the negative 4th.
It is 4.
5 to the negative 4th, right, to make it, to reciprocate the fraction. Over 25 is going to be 5 squared
Wait, I did 20.
to the 1 minus x. That's fine. And then 25 is 5 squared. Either way, this answer will work out the same. All right, so I rewrote everything with a common base of 5, excuse me. So I got negative 4 minus this thing here, which is, I'm going to put that in parentheses, okay? So it's 2x, or 2 minus 2x, be careful, equals 2. Keep it going. Don't forget to distribute the negative. Negative 4 minus 2 plus 2x equals 2. Almost done. Negative 4 minus 2 is negative 6 plus 2x equals 2. Add 6 to both sides. 2x equals 8 divide both sides by 2, and x is equal to 4.